Hello dear friends, my name is Madi and I'm here for teaching the complete course of CCNA Routing Switching 200-301 from the basic of networking into medium level of Cisco networking. What we will learn in this course, we will start from introduction to TCP IP networking, IP addressing and subnetting, fundamentals of WANs and IP routing, and configuring this Cisco switches and routers based on command line interface CLI, basic management of switches and routers, implementing Ethernet VLANs, routing protocols, spanning tree protocol, configuring advanced configuring for Cisco routing protocols such as OSPF, fundamentals of IP version 6, and all of items related about IPv6, securing wireless networks, wireless network architectures, building a wireless LAN, and so on. Okay, let's go to start the lesson 1, introduction to TCP IP networking. First of all, it's need to describe you about computer networking basics and concepts. When the computer networking started, many of vendors and OS producers such as Microsoft, IBM, Novel Netware, and so on, all of them, each of them work with its own routing protocol. So when you need to set up a network, you had to select all operating systems of the same type so that they could transfer data to each other. This was a problem. Organization of IEEE, the organization for defining networking standards, defined 7 steps for making the standard data known as OSI layer. Okay, let's see that. OSI layer, layers, application, presentation, session, transport, network, data link, and physical. These are was 7 layers of OSI layers. When you want to send data from your computer, you as the user, you are working as a user with application. For example, you want to send an email, you start with application, with email applications such as Gmail, Outlook, and so on, and data encapsulated for first time, for first part. Then data transfers to the next layers and specify some data encryption protocols and so on, and then transfer to the next layer is session, for session management of computer networking, starting this session for negotiate between computers or end of negotiation, and then transfers to the next layer. Transport will choose type of transfer protocol such as TCP and UDP. I will discuss later. And then transfers to the next layer, network address for IP address, and data link layer for defining MAC address, and then finally transfers to physical layer, that the Ethernet or cabling, and sent to the receiver, and the receiver computer receives first from the physical layer and remove that header, and then transfer to the above data link layer, read the MAC address, and transfer to the above network layer and read IP address, and TCP or UDP, session management, encryption, and so on, and some other issues. And then finally, the receiver will receive email address, email in the mailbox. Okay, this is OSI layers, but OSI layers changed after many years. It changed to TCP/IP model. That's some layers, application presentation, abbreviated in one layer, known as application. So in this model, we have 5 layers, and now they are used as a standard communication model in all networks. Application presentation session, abbreviated in one application, and this we did discuss about that. And now considering the transport layer, transport defines the type of data transfer protocol, which is divided in 2 parts, in 2 types, TCP and UDP. First of all, TCP. All connections or all communications with acknowledgement included in TCP, and all connections without any acknowledgement, without needs any acknowledgement, are included in UDP. What's TCP? Imagine we have 2 computers, the client and the server. This is the web server, and clients need to communicate with that and request its web page. Okay, I sit behind this client and open the web browser and type address of this web server. When hit enter, my computer or my client sends a request with get home.html or home.html needs to receive the home page of web page, and server, when received, first make the header known as HTTP header, because the request was HTTP protocol. Send OK within the HTTP header, and beside that send data of homepage, data of homepage. Sequence 1, first part of web page, sequence 2, sequence 3, and so on. When the client receives all packets, it considers the checksum for each packet, and know the second packet or sequence 2 occurs an error. So request the sequence 2 or the second packet again, send and says to the web server, I need the second packet again, and the web servers send it again, and until all communication or all connections completely receives and all connection completely finish. Okay, so TCP connections are connections that needs acknowledgement for each packet. Ensuring that information is received is a priority in TCP communications, not fasting or not speed of data communications. Just you need ensuring that the information is received. But UDP, imagine there is the radio or television tower, and the television or radio device is here, and it sends the radio or television signals. The connections that priority is speed, not ensuring that ensuring of receiving data. All of that connections are are made as UDP, data transfer protocol. UDP header and sending media, first packet, second, third, and so on. Connections without any acknowledgement, even if error occurs, and speed of sending data is a priority. In computer networking, many of communications are TCP, some of them UDP, and also in data communications, the communications which needs more speed and more fast packet receiving operates as UDP, for example, voice over IP or VoIP networks. Okay, well, now let's look at how to address systems in the network, which is very similar to the post office system for delivering letters. We have some postal office in the city, and all of these post offices are connected together. When the sender letter send its letter into the post box and receives the letter into the local post office, the post service sends that letter from the fastest and best way to the destination and delivers it to the receiver of letter. Like this, computer networking is similar. In computer networking, some telecommunications office present in city, around the country, and when the computer sends data, want to send data to the destination, starts with one modem or one any other device for connecting to the telecommunications. All of the telecommunication offices are connecting or communicating together with devices known as routers. They know and identify the best way and the fastest way to the destination, and they know each other. When your computer send data, they receive data and sends it to the destination. Okay, the sender and the receiver has the address. The address we know it as IP address, the unique identifier address for each computer or each computer-based device in the computer networks. The address is in 4 parts, each part known as octet, or each part called octet. So we will discuss exactly later in this course. For example, source address 1.1.1.1 quad 1 and send the data to the destination address quad 2, and data routed by routers into the destination. So what's benefits of IP address? When a system wants to send data to its destination from quad 1 to quad 2, okay, when a system wants to send data to its destination in the network, the source and destination address are included in the packet header, and routers can route the packet based on that to be received by the destination system, like this. Okay, so all computer-based devices such as routers, switches, wireless LAN routers or modems, or computers, laptop, smartphones. All of them have IP address for communicate based on that together. Okay. Now I start well, let's check the data link layer. Data link layer contains an address called MAC address, that's layer 2 address, and provide layer 2 communication known as Ethernet address, and Ethernet header adds to the packet beside the IP address, and sending through router, switch, and all of layer 2 and layer 3 devices, and transfers to receive by destination computer. When we want sending the data, for example, start from the physical layer, when the data just in Ethernet or physical layer, it's called bit. When it transfers to the higher layer, it's called frame. And when have the IP address of source and destination, calls packet. And when adds TCP or UDP, it's called segment. And the upper layers called it will we will known as and calls it as data. TCP IP versus OSI model. OSI have 7 layers, but TCP IP have 4 to 5 layers. Physical and data link layers equal network interface. Network layer in OSI equals to network layer in TCP IP model. Transport layer in OSI equal to transport and defines the TCP or UDP data transfer protocol. And session, presentation, and application layers in OSI equals to application layer to TCP IP model, and defines the protocol of application for sending data. Okay. What's the hardware structure of networks? We need 3 categories of hardware to set up a network. Includes network cards or network interface card, known as NIC, switch, and network cable. The switch for starting of making the network commonly will be Cisco layer 2 switch, such as model 2960 or 2950 models. Each Cisco switch starts with number 2. It means the switch is layer 2. What about layer 2? Layer 2, let me show you again. Layer 2 is here. It's data link layer that contains MAC address. I will discuss as soon in the I think it's in the next slide. Okay. So each Cisco layer that starts the model number with number 2, it shows that that switch is layer 2 switch that identify and communicates between computers as MAC address or layer 2 address. So for running and setting up the network, we need the layer 2 switch in, for example, in each floor or in each building, based on how many ports we need. We need to connect computers to each of these ports. This is 48 port switch. Maybe you need 24 ports and more than, or maybe you need more than one 48 port switch. A switch put it here. The Cat6 cable first head of Cat6 cable is put in one of the switch ports, and the second head is put in the network interface card, and therefore making easily the network of computers, all of computers connected like this to this switch. Also, our switch may have a fiber optic port. These ports are known as SFP, are usually used for communication and data exchange between switches, and commonly each layer 2 switch or layer 3 switch have maximum to 4 SFP module for making communication via fiber optic cables. But how do they set up networks in reality? Imagine we have a 4-story or 4 floors building with a switch on each floor, and the computers on that floor are connected to that switch. Then we can connect the switch of each floor to a main switch to communicate with each other. Keep in mind, we can make and define some rules and policies in this main switch, as well each floor switch for providing or protecting from some computers to connect to each other. Maybe we want some computers don't allow to communicate with other computers to the in the other floor, and so on. Presence of this main switch will help us exactly for providing more and more security for control data traffic. But coming to the MAC address, the MAC address is a unique address for each network card that is assigned by the network card manufacturer, and contains 12 hex digits, and divided in 2 parts, 6 hex digits, known as OUI, Organizational Unique Identifier, that assigns by IEEE organization to the network card manufacturer. And the second part is another part that contains 6 hex digits, called unique address assigned, which is the exclusive identifier of the network card. So no two network interface cards in the world are with the same address. Each network interface card has a separate, especially and unique address that we called it MAC address. Now let's take a quick look at how systems are connected in WAN networks. Imagine the systems of 2 buildings on 2 sides of city or country and far from each other. They want to be connected. Well, one scenario is connect buildings using a wireless network, but this is not possible if the distance is too far or there is an obstacle in the way of wireless communication. So in this case, we will need to network to make network the systems using the existing telecommunication infrastructure in the city or country. When you want to communicate systems using the telecommunication infrastructure, there are some protocols between telecommunications, and we need to use that protocols. For example, LAN 1 and LAN 2 are 2 buildings. Okay. Each of these buildings has the router that connected to the telecommunication, local telecommunication, and these two telecommunications connected to each other via maybe various protocols such as HDLC, Ethernet over MPLS, based on fiber optic or point-to-point wireless communications. This is the, some scenario for connecting to LAN network that far from each other. Okay, and when you want to send the packet, the Ethernet packet from the LAN computers to the switch, and switch to the router, and from the routers Ethernet packets with IP address of source and destination, source of this router and destination of this router, and sends to the telecommunications, and in this between the telecommunication switch and routers exchange exchange the headers of packet from Ethernet to EO-MPLS or Ethernet over MPLS, and receive the destination local telecommunication, and change back into Ethernet, and receives by the destination router and the destination LAN. Here the first lesson is completed. I hope it was useful. If you have any question, ask them in the comments, and I will be happy to answer them. Please don't forget to subscribe to notified when the next videos are uploaded. Let's go to the next lesson.